All right. Hi, everybody. Very good afternoon to all of you on this Sunday morning, uh, or Sunday afternoon, rather, I should say. So glad of all of you to join. TCS Digital is corner, and I hope you guys get something interesting and useful from this one. So just 1 second. All right. Hi, everybody. Very good afternoon. And there's just a confirmation from YouTube that you can actually hear me. All right, cool. So what I'm going to start with is a continuation. Now, for those of you who've been following us on this series, in the last two classes. So in the last class, we talked about a couple of questions, and these were the questions that we were speaking about. Number one is evaluate Boolean expression. Then we said that we'll cover a little bit of n queens, and we'll see how that can, help you and solve this question called Sultan sum. Then there is the card game question, auction number question, and wander path. So these are already questions that are on the list. If you have more, please let us know. We will have time to cover only these, but if you still get more, and if there's a lot of interest, we could probably continue as well. All right, so with that having said, let's get started. So evaluate Boolean expression. Last time around, I had already covered this one, and I had covered this using Python. And in Java, one edge case was remaining, right? One edge case was remaining. So let me try to solve this question now using characters instead of strings. I think we overdid the string part a lot last time around. We did not really need to use that much of strings. So I'll actually open that code also just to show you all that I feel that, we were doing too many string operations there. That's why it's giving us a time limit exceeded. Okay, so this is the evaluation last time around, evaluate Boolean expression. And what we did was we were, for those of you who are familiar, who are not familiar, just joining us right now, the question basically states that you will be given a combination of 0, 1, A, B, and C. 0, 1, A, B, and C is what you'll be given. And what you need to do in this question is like 0, 1, A, 0, A, 1, B, let's say 0, C, right? So it's 0, C, 1, right? Something like this. So what A stands for here, A is equal to and, B is equal to or, and C is equal to XOR, right? And what you need to do here is that basically substitute that value, and it's evaluation from left to right. You don't have to care about precedence. So 0 and 1, 0 and 1 will give you 0. 0, B, 0, that 0 or 0 will again give you 0. And now that 0 XOR 1 is going to give you 1. So the answer of this would be 1. And in the last class, for those of you who are not there, you can go ahead and check out the recording. We did this in Java, and then we did this in Python. And in Java, we faced a time limit exceeded. I'll show you all also what the time limit exceeded is. So when we actually run it, you get all the questions passed, all the test case passed, except test case 5, which is a particularly long test case. So that's the issue that we're getting. So let's try to rework this one. We are trying to use strings, and we're trying to generate a string every time. Instead of that, let's try to rework it using characters and without using any extra string. So what do I mean by that? What we're doing right now is we are doing 0A1. So what I'm doing is I'm extracting in the Java solution. What we did why we're getting TLE, why we're getting TLE is because we are extracting 0 as a string, A as a string, right? And 1 as a string, which is fine to do. But except once we evaluate 0A1, we are again manipulating the original string and saying that let's say 0A1 becomes 0. Now we are saying create a new string that looks like this, B0C1. Now, if you again and again do this, the string is going to, get too cumbersome because Java string operations take time. If you're going to do too many string operations, then you would preferably go for string builder in Java. But I want to show you here, you don't even need to do that. You can just do it using characters and just by traversing through the strings. So how does that work out? Let's have a look over here. We'll not actually touch this word like this. And instead, let me just, try to bring that outside. And I'll say, you know what? Now, first things first is we are also checking for invalid case. That's always there. We'll traverse through the array, right? I is equal to 0, or traverse to a string rather. Word.length, right? I++, right? This is what we'll do. And we'll take 3 elements at a time every time, right? So we're going to take 3 elements at a time at every time. So I'll say, the operand 1. So I'll say char op1 is equal to word.char at I. So what this will do is it will ensure that I am not creating a new string out of it. I'm just getting a character. I'm saying char, operator, the char operator is equal to word dot char at I+1, right? And char op2 is equal to word dot char at I+2. Okay, so this is what it's, now I get this. Now, before I even go ahead and try to call the evaluate function, you have to realize that it might just be that I don't have that many characters. So let's say the edge case here is, it is 1A only. So I don't get an OP2 over here, right? I get only one and I get the operator. So this is invalid, by the way. If it's invalid, so what we'll do is, if I+1 less than, if I+1 greater than equal to word dot length, right? So we'll say invalid equal to true, right? And we'll also say else if I+2 greater than equal to word dot length, right? Then again we'll say invalid equals to true, and in both these cases we should also just break out, right? Because if it's or we can break out later as well, so we'll do that. So invalid is true. Now if in both these cases it's not invalid, that is if not invalid, then you go ahead and you try to check out the answer over here, right? So you're going to try to check out whatever the answer is. So you get the operator, you actually get the operator and the operand 2 over here, right? We can also do it like this. We'll actually just define these above only, operator and op2, right? So then that way we don't have to define them here. Okay, operator and op2. All right. So I got these over here, and then we do this, and now we're going to evaluate also. So we'll say, let's say we'll keep the answer also ready with us, and initially, we'll keep the answer as -1, and I'll say answer is equal to evaluate op1, operator, and op2, right? So I'm going to get the evaluation of this one. What's the evaluate function? The evaluate function is over here, okay? And in the evaluate function, let's return an int instead of returning a string. I'll tell you why, okay? Right. So anyway, this is what we take over here. So we take that, op1 dot equals, so if it is equal to 0, so this will be char, by the way. Now all of these are char. This was our earlier evaluate function, and char. Okay. Now we can just say equals to, instead of doing that, we say equals to 0, right? And here equals to 1, equals to 1. Right? So we'll do this for that's 0. That's op1. This is for op2. So if they are not that, then I'll just return -1, and this will be an integer only. So I don't need to keep it as a string. I'll return as an integer. Okay. And operator, actually let me return a character over here. That would be better. Character would be better. Char would be better here. Instead of returning an integer, let's return the character. Oh wait, you don't have a -1 character. My bad. You're just going to return an integer. Let's return integer. Okay. Cool. So return the integer. And again, in this case also, it's going to be equal to, by the not like this, we can just do not equal to 0 and not equal to 1. That would be better. And same here. We'll just make this as op2. Right. And same thing with operator. So operator not equal to A. So if the operator is not an A or a B or a C, right? In that case, right? So if neither an A nor a B nor a C, then you return -1. Otherwise, what you do is you're converting these, op1 and op2 into integers. You can just do that using usual typecasting as well. I don't think you need to do this, but okay, we're fine with that. A and I and J, and now we don't even need to do this string. Right, so we don't need to do string, and otherwise we return -1, right? Okay, and this would be case A, because we just made it from a character string to a character. Right? Cool. So I think this should work out. All right, return -1 here. Okay, now what's happening here is I calculate what is the answer from 1, like operator 1, operator 2, and operator 3, right? Now, the thing you have to realize is, what is OP1 here? OP1 is the word dot char at I, right? Well, it's not always the word dot char at I, because let's say you have something like 1A0, let's say 1A0, B1, something like this, right? So when I do 1A0, it will become 1 and 0, it becomes 0. Now that 0 becomes our operator 1 at this point. Now that 0 is actually going to become our operator 1 at this point. So what I need to do next time around is, in the first case, this works out fine. But at every other time, I just need to make sure that my operator 1 is actually the answer over there. So I'll just say if answer equal to -1, we've still not got it. So it should be word dot char at I, right? Else, right, OP1 is actually equal to answer, whatever is the answer you've got so far. We would need it to be a character though. So I guess yeah, we would need it to be a character. Yeah. Okay. So we'll just convert it to an answer like that. Yeah. Then we do this. And so now every time what we're going to do is, yeah, or in the other way, what's even easier to do, yeah, we'll do it this way. Int answer is equal to word dot char at 0. We start with word dot char at 0 over here, and we just convert it to an integer, right? So we're going to convert it to an integer like this, word dot char at 0. Now we're going to start at 1, and what we will need to do is, we will also need to see, yeah, I plus 1, I plus 2. That's great. If not invalid, operator is, I, and this is I plus 1. And we do here, I is equal to I plus 2, right? So we'll go to index number 1. We'll go to index number 3 after this one. And answer is equal to this. And I'll say here, OP1 is equal to answer always, right? So OP1 will be equal to the answer. So in this case, why am I even bothering with, okay, fair enough. Let's do this. Yeah. Okay. When I come out of this, I'll say if invalid. If it's invalid, then you just print out -1. Right. And here also, if answer equal to -1, then you say invalid equals to true, right? Yeah. Before I even do this, I just check if invalid, I'll break out from this loop. Okay. So just basically reworking the entire thing. Now, if it's invalid, do this, else you print out the answer. Let's see if this works out. I think there will be issues. 8, 6, and 8 line. Yeah. I think in the switch case. Okay, here. All right. Char cannot be converted to string. All right, cool. That's fair enough. We'll just do int I is equal to int of OP1. And here, int I is equal to int of OP2. So let's see if that works. Okay. Have we already defined OP1, OP2? Okay, we had already defined here. So we remove the string part because I said we're going to do it in characters. All right. So we're getting a -1 here. Let's try to see why we're getting a -1. Okay. So answer equal to -1. Okay. OP1 is equal to char of answer. Answer is equal to evaluate this. And then we do that, right? So what is it coming out here? Is it even printing the answer? Is it reaching here? So we're missing some case. Okay, it's 48. Got it. So it's basically the issue is we are when you convert a character to an integer, what you end up getting is the ASCII value. So if I wanted to print for 0, the ASCII value is 48, right? So whenever I wanted to convert it, I should make sure that I do yes. So you're saying to convert a character into number, use character get numeric value. Yeah, you can do that, or you can just use what do you say? You can also just use the ASCII value, so that's also fine. So let me just see wherever I'm converting to an integer, right? Int is equal to OP1, and I'll just do -48 here, right? So first I'll do this, convert it to this, and do -48. Same thing here also. Whenever I convert it, I just do -48. So that way it's an ASCII value, right? So we can get the ASCII value out. Okay, so that's the case. This is fine. That's the conversion. Where else are we converting to an integer? We are int answer is equal to int word dot caret 0 -48. Right? Let's do that. Yeah, we can just do -48 because of the ASCII values. Answer 1, answer, that's fine. That's fine. And when we convert it to a character, we should also do +48 over here, right? Okay, let's see now. No, it's still giving us -1. What could be the reason? Let's just probably just see OP1. So OP1 over here, OP1 over here in the first case scenario, should be answer +48. Sorry for that. Notifications here. Yeah, we're making some. Okay, we'll see what's the issue, but it should be ideally in the first case it should be 1, yeah, which it is, but after that it's not coming, right? So after that it's never actually coming and printing here. So what should ideally happen? 1 is 0 is what should happen, right? And after that 1 and 0 should give me 0 actually, but I'm not getting 0 the next time. I'm just getting OP1, right? This is the I'm just getting -1 over there. So what could be the reason over here? It's probably because of this case. If OP1 not equal to this and OP1 not equal to -1, return -1, not equal to 1, OP2 not equal to this, return -1. Okay, so what is the scenario over here? Let's print out these two values also to see. See what's happening. So it's just a basic conversion issue that we're facing over here. Let's see. What is the issue? Yeah, so it is giving 1A0, it's giving, but the next time around it's not giving, right? So what is the issue there? Let's see the answer over here, right? Let's see here. And again, guys, if you get stuck, you can always, do this kind of a debugging. Always helpful. Let's see now. So what's coming here? Okay, 1A0 works fine. And let's also print the answer. Answer over here. Let's print that. Saying 1A0 equals to 0. Okay, so till 0 it was fine. For some reason we're not getting after that. So 1A0 it was fine. If answer equal to -1, invalid is equal to true. Okay, that's fine. If I +1 and okay, but are we getting I? No, we are not, right? So we need I and I plus 1. That was the issue, right? We were first doing I plus 1 and I plus 2, but now we just need I and I plus 1, right? That's the thing. So if I run now, yeah, now we're getting the correct answer of 1 right over there. So let me just hide all these debugging statements. We will hide all the debugging statements here. Let's comment that out, and let's also comment this out. Okay, so our conversions all seem to be going correct. Yeah, so it passes that test case. And yeah, so test case 5 is the first to pass this time around, right? Which was causing us trouble last time. Okay, so basically everybody, instead of creating a new string every time, don't try to do that in Java. Don't try to create a new string every time. Just do a conversion from a character. You're absolutely right. Somebody has mentioned on the chat that you can just do character.get numeric value. Absolutely correct. You can do that also. That's also fine to do, right? I prefer ASCII values. It's just something comes naturally. That's it. So yeah, everybody, this was pending from last time. So hope you've got an idea now that in Java, one edge case was remaining. Now it's done. So we are done with this part. Okay. Now, before I come to end queens, which is a slightly more complicated thing, we'll focus a little bit on the auction number, right? And we'll also look at this card game, right? So just want to get these questions out because these are likely to come tomorrow. So let me just get this out quickly, and then we'll wrap up with this thing, end queen, Sultan, and I'll give you the logic for wander paths also, which I think I've already covered earlier, but still. All right, let's have a quick look at auction number over here. What is auction number? So this is a typical TCS digital question wherein you are getting a lot of words. It's a lot of words, but actually the code is pretty straightforward. It's going to be not too difficult. It will be straightforward only. Okay, let's look at it. So Kodu has found a vehicle numbers. He wants to compute the number of vehicles that can be registered in his state. A vehicle normally has a registration number state, then some number, then AB, and then some number. The first part has 2 letters common for all cars in the state. The next 2-digit number is the number of district where the car is registered within the state. It is always 2 digits and may have a leading 0. After that, the next part consists of 2 letters. So that is this AB, right? 2 letters denoting the series. And the last part is a 4-digit number, and it will always be 4 digits, even it has the leading zeros. Okay. The entire registration number is unique to each vehicle. You have been given the number of districts in the state and a range of letters and a set of digits that can be used for forming vehicle registration number. You need to find the maximum number of vehicles that can be registered with non-special number subject to the rules. The state has identified some numbers as special and will not be issued normally, but will only be available by auction. In these plates, the last part consisting of 4 digits has 3 or more repetitions of digits, such as 0001 or all zeros or 0100. Basically, one digit is repeating more than is repeating 3 or more. Could be 3 or more digits. Okay. So I need to find out all of the non-special digits that are possible. I need to find out all of the non-special ones that are there. Okay. So what you're getting is first line contains number of districts in the input. Let's again have an understanding of this one. There are 4 parts to it. If you just break down the question, everybody, this becomes very simple. Okay. Auction number. There are 4 parts to it. The first part is the state. Okay. 2 characters. Then the districts, 2 digits. Then there is some, right? After that consists of 2 letters denoting the series. So this is called the series. Again, 2 characters. Okay. So the series containing 2 characters, and then a number, 4 digits. 4 digits. All right. So far, so good. Let's note down the condition for each one of them. Okay. So what it's saying is, first line contains the number of districts. Okay. So the first line contains the number of possible districts. So you have over here, it's a 2-digit, but you have all the possible districts that are there. Okay. So this will be given, right? Number of digits, number of districts will be given. Second line contains range of alphabets. For example, if the range is B to F, any of the letters B, C, D, E, F may be used in any combination for the 2-letter series which comes before the 4-digit number, right? So that before that, that's a series. So they will also give you range of characters. Range of characters will be given. Any of these characters can be chosen, and they need not be unique, by the way, right? So in this case over here, you can have like BB is used, right? And so on. Okay. So that's another thing. Third line contains range of digits. For example, if the range is 3 to 6, any of the letters 3, 4, 5, 6 may be used in any combination for the 4-digit number, which comes after the 2-letter series. So again, range of digits will be given. Range of digits will be given. Now, they are not going to give you anything about the state. So you don't actually worry about the state. Okay. That's constant. So you don't have to actually worry about this. Now the question essentially becomes, how many non-special numbers you can do. So before getting to the non-special numbers, let's try to get the total number. And then we'll do total minus special will give us the number of special ones. What is the special one? We'll come to it. But if I just look at this formula that they've given us, that this is how we'll do it. How many total are we going to get? How many total digits are we going to get over here? So total, right? Total possibilities that we'll get. We'll get number of districts. So that is districts. How many of districts are possible, right? Into the range of character will be given. So if I can figure out all the permutations, okay, if I can figure out all of the permutations of these characters. So let's say series permutations, right? If I can do that, into range of digits will be given. So if the range of digits are given, again, I need to find out digits or other number permutations. Okay. What do I mean by this? Let's look at the example over here, right? So let's say they have given us, first is state 2 characters. We don't care about that. For district, let's say they give us, there are 3 districts. So they give us 3 districts. Then they're giving us the series that the range will be there, right? So in this case, they have given us BB. Let's say it is BC. That is from B to C, I can use anything. So what are the possibilities? What are the permutations that are possible over here? I could have BB, BC, CC, CB, right? Basically, how many numbers will be, how many elements can be put at every point? Because repetition is allowed, right? At every point, if there are n numbers here, right? Let's say there are n numbers here, n over here, right? I could put n over here, n over here, n over here, and so on. So actually speaking, it's going to be n raised to n, right? If I'm not mistaken, is that correct? So it's going to be 2 raised to 2 here. Let's also have a look at this. If there was BC, if it was BD, then I could actually do BB, BD, and yeah, I could do BB, BD, and DB. So starting with B, there's only BB and BD. Oh, sorry, I could do BC and BD. Yeah, because there's from B to D, right? So I'm allowed BC and D, right? Then I could do CB, CC, and CD, right? And then I could do DB, DC, and DD. There's no other thing that I could do because always the 2 elements, right? So at every point, I can do n elements, and there are totally no, so it's not n raised to n, sorry, it's n square. It's n square. It's not n raised to, it's n square. Because if I take 2 blanks, it is n in one and into n in another. So it's n square. So I can do totally n square here. So it comes to, total so far our formula comes to, what is the number, whatever is the number of districts into n square, that's the series permutation, into the numbers permutation. What do you mean by numbers permutation? So let's say I have a range of digits. Okay. Let's say I have the range given to me over here was, probably, let's duplicate this again. Yeah. So if I'm looking specifically at the number, 4 digits and range of digits will be given. So let's say if it was, the range was, let's say 1 and 3. Okay. So at each step, I have what choices? I could use 3 choices over here because 1, 2, or 3 I could use, or 3 choices over here and 3 choices here and 3 choices here. basically whatever is the range raised to 4, right? So number of elements in the range, which is, so range raised to 4 is what I could do over here, right? That is what will be the total number of possible ones, right? Total number of possibilities that I can have. Because the numbers can repeat. It's not saying that numbers cannot repeat. Right? Okay. But it's also saying here it's 1, 2, but 0 is, no, here 0 is not a possibility. Here it was 2 districts, right? By the way, it was 2 districts. So you had 0, 1 and 0, 2. Okay, fair enough. That's right. So that's the total number of districts. That's okay. All right. Okay, so let's just try to write it. It's both same in Python and Java. I'll just do it quickly in Python, but it's a simple mathematical formula to get the total number, by the way. So this is the total number, right? That's the total. It's still not the answer, but it's the total number that you want to get. So in this case, let's say districts is equal to int input. Okay. After that, I'm going to get a range of series, right? So series start is series start, comma, series end is equal to list map int input. No, it's not even input.split. It's a series start and end, right? And what is there in the series start and end? You are going to get 2 characters over here. Right? You're going to get 2 characters. So I'll just do, they're going to be space separated. So I just do input.split, right? So you'll get the start and end on that. So what is the range of the series, or rather I'll say n, which is what we said for the series, is I want to get I'll use the ASCII value here, series end. This is nothing but it gives me the ASCII values minus series start plus 1. Because let's say you're given B and B, it's going to give you 0, and then you need to do plus 1. It's given B and C, whatever is the start minus end minus start plus 1, right? C minus B plus 1. So you get 2 characters there. Okay, that's cool. After that, what am I going to get as the input? I am going to then get also the range of numbers, right? So again, I'll just say range start, comma, range end. Here they're integers. So I'll do list map int input. Here it's an integer. And what is the range? Total range is equal to, okay, that's a keyword in Python. So, range n, let's say range n is equal to range end minus range start plus 1. Okay, range end minus range start plus 1. Now total, what did we say the total? Total is how many of our districts you have into n square into whatever is the range underscore n raised to 4, right? That's how many total. That's the total number of possibilities that you have, right? That's the total possibility. However, now comes the next part. There are certain special ones. Which are the special ones? The special ones, everything remains the same except in the last part, that is the digits. What did we call it again? We call it the number, right? So the number has greater than or equal to 3, has greater than or equal to 3 numbers, right? Same numbers, has greater than or equal to 3 same numbers here, right? And we want how many non-special ones? Non-special ones, right? That's what we want to do. Okay. So if number is greater than or equal to 3 same numbers, the only thing that changes here is this. Here we said these are the total ones, right? These are the total ones, where what we said was the number permutations. If I look at it here, we called it as the range raised to 4. We called it as range raised to 4. That's what we did here. What does that mean? If you are given the range, let's say you're given the range 1 to 3, right? You could have 1, 1, 1, 1, 1, 1, 1, 2, 1, 1, 1, 3, right? At every possibility, you had 3 possibility, and all those 3 possibilities raised to 4 is what we are doing. Now we are saying some of those have to be discarded. Which one have to be discarded? Those which have at least 3 or more, right? Okay. So what does that mean, having 3 elements, right? So it could have 3 or 4 elements. Okay. So let's say the one which have 3 numbers. How many are there? The one which have 4 numbers, we know how many that are going to be. It's either going to be 1, 1, 1, 1, 2, 2, 2, 2, or 3, 3, 3, 3, right? So I know this is going to be range. 4 numbers, all 4 the same. This is going to be whatever range we have. That we know for sure. But how many are there which are having 3 numbers? Okay. So when I say 3 numbers, what does the 3 numbers look like, right? It means that at any point of time, 3 numbers are occupying by the same one, and only this one is occupying by a different number, right? So it's going to look something like x, 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 y, right? And then x, x, y, x, and then x, y, x, x, and then y, x, x, right? That's what it's going to look like. So how do we figure this out? How many different ways are there of organizing this? This is nothing but it's actually as 4 factorial divided by 3 factorial, right? Is what it's going to be. There are going to be 4 different ways of organizing this x and y. Okay. But now the thing is, the x and y is also changing every time, right? So the x and y itself is going to change every time at that point. Because first you'll have like 1, 1, 1, 1, right? And then you'll have all the numbers. So let's say, for example, with just 1, 1, 1 itself, right? What will you have? You can have, 2, you can have 1, 1, 1, 3, you can have 1, 1, 1, 4. Let's say the range given to you is 1 to 4, right? And you could actually have had 1, 1, 1, 1 also. No, okay, let's not get into that. Yeah. 1, 1, 1, 1, oh, sorry, 1, 1, 1, 2, 1, 1, 1, 3, and 1, 1, 1, 4. And each one of them will have 4 different combinations themselves, right? Because 2 could be here, 2 could be here, and 2 could be here, right? This is for each number. So what does that mean? For 1, you will have 4 such combinations, right? For 1 and 2, you will have 4 such. For 1 and 3, you will have 4 such. For 1 and 4, you will have 4 such. Here you'll have 12 combinations. Then again with 2, you will face the same thing. Again, 12 combinations and so on. What are we getting at? We are getting, it's going to be 4, because you'll have for each of those combinations 4, into, for 1, 1, 1, 1, you're going to have how many? You're going to have range minus 1, right? You're going to have 2, 3, 4, right? But you're going to have range minus 1 because there are 4 elements, but you're saying range minus 1, right? So you're going to have these many, right? For the range minus 1. Yeah, this is going to be there just for 1 itself, right? And like this, how many are there? There are range elements. So there was, for 1 you did it, then you'll do it for 2, then you'll do it for 3, and you'll do it for 4. So for 3 numbers, it finally comes down to 4 into range minus 1. That's what it comes down to, right? And for range, and for 4 numbers, you'll have range numbers, right? Range meaning like for between 1 to 4, here range is equal to 4. You have 4 elements altogether, right? Okay. So what does it mean? Totally special is going to be 4 into range minus 1 plus range. This is what you're going to get as your special numbers. So non-special will just be total minus special numbers. Total minus special numbers is what you're going to have. Okay. So let me just take this and try to put that here. Right. So it's not range in our formula, it's range underscore n. Range underscore n. Right. So these are the special is equal to this. All right. Special will be equal to this. So the total non-special, so total is equal to total, rather not total, non-special, non is equal to total minus special. And I'll print non over here. These should be my non-special ones. Let's see. Okay. we're getting a wrong answer because here it's saying 22. We are getting 22, but answer should be 12. Okay, let's go step by step and try to understand where we could have possibly gone wrong. Range n-1 and range n, right? Is that the total special that we can get? Let's just see here if anything else in the special one. The last part consisting has 3 or more repetitions of digits such as so on. Okay, the output that can be registered with non-special numbers. Okay, range of alphabets, range of digits. Okay, so BB and 1 2. Okay, let's try to see if our answer is correct for BB and 1 2 just per our logic itself, right? As per our logic first of all, and then we'll see do we have any issues over here. Okay, so this is the input that's given over here, right? Total number of districts is 2. The n over here is 1, so you can have like 1 square is 1, and the range here is 2, so 2 raised to 4 is so this becomes 2 raised to 5, which is equal to 32. So I have 32 possibilities here. Is that correct? There are total number of possibilities is 32, because for each district you're going to have okay, I think we made a mistake here. It can't be range raised to 4. It can't actually be range raised to 4, because you will end up getting duplicates. You're actually end up going to getting duplicates. So like you'll have 1 1 2 2. Yeah, you might actually end up getting duplicates over here, right? So you can't do, like, for example, 1 2 1 2, then you can't again have that, right? So how many? This is 1 1 1 1 2 2 2 2 triple 1 2 and so on, right? So 1 1 2 2. Okay, right. I think, yeah, here we probably made a mistake, because are you going to have 2 raised to 4 elements there? 16. Can we generate 16 from this one? Yeah, we can, right? I believe we can. Okay, let's just play out the entire thing. Let's say it's 32. Okay, so let's say it's 32 there, and here what we're saying is now the special ones of them, the special. Oh, okay, I think we made one mistake here, where in the special we didn't multiply the districts, right? Yeah, we have not done this part, which is districts into, yeah, we didn't do that, right? We just did this over here, but we didn't really calculate how many special, right? Districts also is going to play a part, and this n square is also going to play a part. Yeah, this we didn't do. I think this was the issue that we got yeah. So now we're down to 14. Yeah, and this should be in a bracket. That was the issue. Yeah, so now I got 12. Okay, yeah, we just forgot in special also the districts and the n square also counts, right? That's what the issue. It was not an issue for calculation. Our calculation is perfect. Okay, simple maths question, everybody. This is actually an aptitude question more than a programming question, right? So if you know your aptitude question, if you know your combinations and permutations, then you should be able to get the answer here as well. Okay, cool. All right, so I just want to check if any doubts or questions so far. If anybody wants me to repeat something right now, please let me know. Right, anybody, anything you'd want me to repeat, please let me know about that. Okay, if it's clear so far, please do say clear. All right, I don't know why I'm getting those messages. Okay. All right, somebody's talking. Hey, nice to see you, Simon, after a long time. Good to see. I just saw this in the chat right now. Yeah, that is the better way. Correct. You are right on the chat. Nice to see you there. Okay. All right. So I don't think any doubts so far. So let me just continue with this as planned. Okay, let's go to this next question. It's called card game. This is also again a what do you say? Tricky question, but if you get, and it's a very step oriented question. So let's go step by step and try to understand what's happening here. Okay, it is tricky, so just follow along over here. Okay, so we're going to this question called card game at this point. Okay, So the question is as follows. You have 100 cards numbered 1 to 100. You distribute them into k piles and collect the piles in order. For example, you distribute them into 4 piles. Then the first pile will contain the card 1, 5, 9, and the fourth pile will contain the cards 4, 8, 12, and so on, right? While collecting back the cards, you collect the first pile, flip it bottom to top, then take the third pile, flip it bottom to top, and put the cards on top of the fourth pile, and so on. Next round, you distribute the cards into another set of piles and collect it in the same manner. So some confusing thing here. Basically, while collecting back the cards, you collect first the last pile, flip it top to bottom, then take the third pile, flip it here again. While collecting back the cards, you collect first the last pile. You take the last pile, flip it bottom to top, take the third pile, flip it bottom to top, and put the cards on top of the fourth pile, and so on. Okay. Next round, you distribute the cards into another set of piles and collect it again in the same manner, right? So what we are supposed to do finally? Given the number of rounds m, find the number of piles in each round k. You need to write a program to find the nth card from the top at the end of the final round. Okay, it's the tricky part. All right, let's go step by step here. If you just replay the steps, you will be able to get this answer. Okay, so if you just replay the steps, you should be able to get this answer, which is, let's try to understand what's happening. Okay, the first thing that's given to you here is m plus 2 comma separated integers. The first number is m, the number of rounds. So let's say you're given number of rounds. Let's say in this case, the example is there are 2 rounds, okay, 2 piles, and the first number is m. Next is k. The next m numbers are ki, which represents the number of piles in each round. The position in the final pile whose value is to be determined. Okay. Okay, perfect. All right. So you have 2 cards to begin with, right? No, you don't have 2 cards. You always have cards 1 to 100. Okay. So you have the cards 1 to 100. Let's say you have the cards 1, 2, 3, 4, 5, all the way up until 100. These are the cards that you have. Okay. Now, if we have, no, we're not saying that. What you're saying is there are 2 rounds, and in both the 2 rounds, you're supposed to create 2 piles. So the thing given to you is 2, 2, 2, and 4. How to make sense of this? 2 tells you number of rounds, right? This one tells you pile in first round. This one tells you pile in second round. Okay, that's what it tells you. And 4 is at the end, you want to find the 4th number from the top. Okay, that's what you do. All right, so let's try to put, what you're going to do is there are 2 rounds. In the first round, I'm going to put all of the cards in 2 piles. When I put in 2 piles, what's going to happen? Card 1 goes here, card 2 goes here, card 3 goes here, card 4 goes here, card 5 goes here, card 6 goes here, and so on, right? So basically in pile 1, bottom to top, pile 2 again. So if I just talk about like this, bottom to top, I have 1, 3, 5, all the way up until 99. For pile 2, what you have is 2, 4, 6, all the way up until 100, right? This is what you get here. Those are the 2 piles. Now what it says is you are going to, how are you going to do it? So you're going to say, okay, right? We flip the piles and then we put the second pile at the bottom and the first one goes on the top, right? So what we'll do is you're going to flip the piles. So this was on top, right? Now when you flip it, after flipping, I get, let's say pile 2 and pile 1, right? So I'm going to first, we flip the piles to get, so all the piles will be flipped. It's not like they'll not be. This will be 100 will be at the bottom. then 98, 96, and so on, all the way up until 6, 4, and 2. Okay. What about pile 1? Pile 1 will have 99, 97, 95, all the way up until 5, 3, 1. So they're flipped. And after flipping, again, let's see, right? We put the second pile at the bottom and the first on the top to get like this. So after flipping, second pile goes at the bottom and the first goes at the top. So what should happen here is final at the end of round 1 is you should get all of these things. So first will be pile 2 at the bottom over here. And then you will have pile 1 come over here. Okay. So this will be pile 1 over here. Okay. This was at the end of round 1. In round 2, again, we are going to distribute into 2 piles. All right. So we're going to actually distribute it into 2 piles. Do the same thing here. Distribute into 2 piles. So let's do it for, so now this becomes our starting point. This becomes our starting point. And now again, we'll say, okay, pile 1, pile 2, because again, there are 2 piles over here. Okay. So what do we do here? In pile 1, we are going to first store 100, then 98, 96, 94, right? 92, and 90, so on, right? Eventually speaking, it will come across to, so all the even numbers are first, right? All the even numbers are coming here first. You're going to have how many even numbers? You're going to have 50 even numbers here, right? 50 even numbers. So 1, 2, 3, 4, 5, 6, 7. Finally, you'll end up having something like 8, 4. No, you will not have something like that. You'll have 12. Yeah, you will have actually something like 8, 4, 6, and 2. You're going to have something like this in pile 2. Then again, it will start from here. 99, 95, right? Sorry, 99, 97 here. Is this correct? 8. No, this is wrong. 8, 6, 4. Yeah, that would make sense. 8, 6, 4. Yeah. So 99, 97, 95, 93, and so on. Again, at the end, you're going to have something like 3 over here and 1 over here. Okay. So is this final is correct? Why would you say it's not correct? What's the issue with this final? What's the issue with this final? So in the question, the final is 1, 3, 5, 99 all the way up till 100. True, but I believe they are doing top to bottom. We are doing bottom to top. Right? So they are doing top to bottom 975. So again, everything here is top to bottom. We are doing bottom to top. So technically ours is correct only. Yeah. We are doing bottom to top. They're doing top to bottom. That's why. Right? All right. So we got this pile 1. We got this pile 2. Now what we do? We again flip. We'll again flip both the piles. So pile 1 has to be flipped. Pile 2 has to be flipped, and so on. Right? So pile 1 will be flipped. Pile 2 will be flipped. What that looks like is another thing in itself. So 3, 5. No, 5 will be there. No, 3, 7. So here will be 1, 5 from the bottom, right? And so on. They will be flipped. At the end, you are going to have, again, you're going to have like 95 over here, 99 over here, 93 and 97. And if I just keep going further, I'm going to have 92, 96, 100, and 90, 94, and 98. All right. Okay. So I did this. After the flip, what do I do? After flipping, you will put pile 2 on bottom. Okay. So you're going to put the pile 2 on bottom. This is what we did over here, right? Put pile 2 on bottom and pile 1 on top of that. So you take pile 2 on bottom and then pile 1 on top of that. So you're going to get 1, 5 all the way up until 93, 97. Then 90, 94, 98. Then 3, 7, 95, 19, sorry, 3, 7 all the way up until 95, 99, and then 92, 96, 100, like that. Now, what does the question say? The question is asking nth card from the top at the end of the final round. Now, on the nth card from the top at the end of the final round. So, our bottom to top is here. So, nth card from the top here, we would want the, in our case over here, we would want the fourth card over here, right? This is what they want. So something has gone wrong for us because the answer is 13. I don't think the answer is 13 over here. Flip, flip. We are doing top to bottom or bottom to top? Bottom to top. This is the bottom, this is the top. Pile 2 comes at the bottom. This one comes at the top. So did we flip it properly? Okay, we might have to do this again. It's a very confusing question, I know, but we just have to follow all the rounds, right? At the end of the round, the deck is in the following order in the top to bottom fashion, right? So they're saying in the top to bottom fashion. Let's see at the end of the first round, are we really getting that? 1 second. We said it following order 1, 3, 5 and so on up until 100, where it's top to bottom, right? So we had 1, 3, 5, so on up until 99, yes, and then up until 100. So we got this part. This is correct. The next one also has 2 points, two piles, and after the second round, the cards are in the order 1, 5, 9, 3. Okay, here is where we made a mistake. In combining these two, we've made a mistake somewhere over here. What is the mistake that we have made? Let's look at this here. Pile 1 that we said, this is bottom to top. So pile 1, we are going to take 100, 98, 96, 94, 92, 90. We made a mistake somewhere. Yeah, we made a mistake here in the following order. Okay. Let's again have a look at this. All right. So yeah, this was fine because this is the top to bottom. Okay, that's fine. The next round also has 2 piles, and after the second round, so what are we doing over here? Okay, this is our mistake. Our mistake is this. We have to always remember, everyone, that it's bottom to top, right? That's what we said. It's bottom to top. Meaning when we start distributing the piles, so when I say pile 1, we have taken bottom to top, right? So we should respect that bottom to top. So pile 1 and pile 2 is like this. What's happening in pile 1, everybody? We have to take from the top and distribute. So 1, 3. So in fact, what you should remember is, because we're doing bottom to top, you should also remember it like this: 99, 98, all the way up until 4, 3, 2, 1. This is how we're actually choosing the cards, and we're always choosing from the right side. Okay. So I take 1, 3, 5, 7, 9, 11, and so on, right? All the way up until this 1, 3, this, I'll go up until I will do 97 and 99. Yeah, now it will come out correct, because we want to do bottom to top. So we're taking from the top, right? First. Okay. Then we do 2, 4, 6, 8, so on up until we reach 94, 96, 98, and 100. Okay. This is bottom to top. Now we'll need to flip it. Once we flip it, what will happen? Pile 1 and pile 2 are going to look like this. It's going to look like pile 1 is going to look like 98, 94, so on up until 6, 2, 97, 9, 5, 1, right? And this one is going to look like 100, 96, 8, 4, then 99, all the way up until 11, 7, 3. Okay, this is after the flipping. And finally, what do you say? Final, you put pile 1 on top of pile 2. So this is bottom to top like this. So you're going to have 100, 96. So you're going to have basically pile 2 like this at the bottom, right? And then this at the top, right? Something like this. Now the question is, get the, what is n? N is saying, I want to get the fourth card from the top. So I want to get the fourth card from the top. I look from here. I have 1, 5, 9, and then it's all going at series of 4, right? So fourth card from the top is going to be 13. Fourth card from the top is going to be 13 over here, right? And that's why the answer comes to be 13. So again, the point is, if we are really careful in the way we are going about things, everybody, we should be fine. We should be able to, basically put all of the elements properly. That's the idea, right? Okay. Let's try to figure out how we'll actually solve this, right? Let's try to figure out how we'll solve this. So we'll be given, first things first is, we all know that n is always 100, right? So the array is always 100. I at least know that, right? So let's call it as like, the array as such, right? The array is always going to be like in 100 at this point. So I'll just put this over here into, let's say 100. Okay. Then next, what we are given is, we are given m plus 2 numbers, right? So we are going to actually be given m first. What did it say? The input format, input and consider m plus 2 comma separated integers, right? So what we do is, input is equal to list map int input dot split. Okay, and this is the input dot split. But to be very careful on the bottom to top part. That's the major issue over here, and that's the thing we have to be super careful about. Okay, so now what we're going to do is, we'll take m is equal to input of 0, right? That's the number of elements. Then the next m elements are all the k's, right? So if I'll just say, like, pile sizes, I'll just say pile underscore sizes, which is nothing but the k's, okay, is actually equal to input from 1 up until, let's say, len of input minus 1, right? Starting from the first one till the end. So these are the pile sizes. And then the actual n, the nth element that we need is input of -1. This is the last element. Okay. So we now got the input format at least, right? So we've got the input. Okay. What next do we do over here? We have to create that many piles every time, right? We have to actually go ahead and actually start creating all the piles at every point, right? So what I'm going to do is, for I in pile sizes, right? For every time in the pile size, I have my array over here, right? So first, let me actually put that array from bottom to top. Remember this one. So I'll first do for, let's say, I in range, starting from bottom, go to, this is the way of, basically this is like for I is equal to 100, I greater than equal to 0, I minus. For those of you who are not from Python, I'll create this array, is array of, better than that, because we want to do bottom to top, and 100 is at the bottom, we are saying, right? So I'll just do this, and I'll just do array dot append. So I'll start at 100, 99, 98, 97, so on, all the way till I reach not 0. So I should do 1, right? Up until 1. No, sorry, up until 0. So it will stop at 1. So 100 up until 1. So now I got this particular array, right? Now I'll get a pile size at every point, right? So let me not say I, let me say k. So I have a particular k. I have this pile size. These are the pile sizes. If these are the pile sizes, then how many piles that I'm going to have, right? So let's say if the pile, these are not the pile sizes, by the way, these are the number of, these are the piles at that point. It's not even the pile sizes, so it's the piles, right? So, or let me call it like number of stacks, right? It's better to say stacks. Yeah. So number of stacks over here, right? So for k in number of stacks, what are we going to do? We're going to say, okay, let's say k is 2. Okay, so we're going to say k is 2. So we're going to go through each of the elements and try to add to the particular stack, right? So I'm going to first of all create that many stacks. So I'll say, current stacks is equal to, right? For I in range. Okay. What this will do is it will create that many empty stacks. Okay. For example, there are 2 stacks that I'm supposed to create, right? That's, let's say k is 2. I'm supposed to create 2 particular stacks. It's going to give me 2 lists within this list. It's going to give me 2 lists within that list. Now what I'm going to do is I am going to go through my array at this point and keep placing elements in one of these stacks till I'm done with my array. Okay. So for I go for, let's say, j in for I in range. It's going to be range 100 only, but let me just do len of ARR because I want to go through all of the elements. Okay. So I'm going to go through all of the elements and I'm going to start placing them in a different stack right now. Right. So I say, my stack at this point, I'm going to always start at stack number 0, right? And keep going to the next stack, right? So I'll first start at stack 0. So I'll say that current underscore stacks of my stack, right? And dot append, I'm going to append ARR I. So I'm going to add this element to the stack. Correct. All right. And then I will also do my underscore stack is equal to my underscore stack plus 1. So that I go on to the next stack. I'll also put a modulo current stacks here so that I can come back to 0 the moment I've reached the last stack. So I'll again come back to the 0th part. Okay. Just for this, let me actually just print current stacks just to show you how the stacks is being created, right? So let me just show you the current stacks like this, just for you to see what it looks like. Hold on. Yeah. All right. So this is just wanted to show you this. So this is how the stacks looks like. Okay. What I'm putting is in the first stack 100 from bottom to top again, everybody, right? So 100, 98, 96, so on is in the first stack, right? All the way up until 2, right? This is happening in the, okay, this is interesting, right? Because we were doing bottom to top, but I don't actually do ARRI. Yeah, this is the other part. I go top to bottom, right? So I should do for I in range len of ARR -1, go up till that -1, right? Yeah. Now let's see. Yeah, now it's coming out proper because we've not flipped it yet, right? So what's going to happen is 1, 3, 5, 7, 9 and all is going to be at the bottom for the first stack, and the second stack is going to be 2, 4, 6, 8, 10, 12. That is what we are getting over here, right? This was in our first thing, 1, 3, 5 up till 99 and 2, 4, 6 up until 100. So we got that here up until 100. What did I do? I just basically created, on demand, I'm creating that many piles, right? On demand, I'm creating that many stacks. So there are 2 stacks here, right? So I do that. Then I'm figuring out on which stack do I start with. So I'm figuring out which stack do I start with. I'm starting with stack 0. I'll go to stack 1. Then there is no stack 2. I want to come back to stack 0. That's why I'm taking a modulo k so that I come back to my stack 0 over there. Okay, cool. And here I'm printing the stacks. I should not be doing that. What I should do is I should again put these stacks. First, I should flip them and then put them back in the bottom to top order again. Right? So I have to be very careful here. Again, it's now all bottom to top. Now both have to be flipped. Okay. What do you mean by flipped? Both of them have to be, all of the stacks have to be actually flipped. How do I do the flip? So I'll do for stack in current stacks. In Python, the easy way to do is, or actually, let's do it like this. For, let's say, I in range k, because that's how many stacks are going to be there. I'll say current stacks of k. This is the current stack of I. This is the ith stack. I need to flip it. So I'll say current stacks of I. And how do you flip it in Python? You just do this. Right? So this will reverse the stack. You can do it in your own language and so on. But yeah, this is actually going to reverse the particular stack. So at that stack is going to be reversed. Okay. All right, great. I did that. Now what's going to happen? Pile 2 will go to the bottom. Then pile 1 will come. So from the last pile, so it's going to be like pile 4, pile 3, pile 2, pile 1, right? So I'm going to start here. I'll go for I in range k minus 1 up until minus 1, right? I'm going to do this. I'm going to say arrange all the stacks such that they again fit your array again. So I'll say array is equal to, I would say actually my array is empty now, right? And I will now keep adding those elements back to my stack, right? So sorry, back to my original array. So I'll say array is equal to, or rather array dot, we can just do extend. So it takes all of the elements from that stack and adds here current underscore stack of I. So let's take the last stack, put at the bottom, then the second last stack, and so on. So let's print out the array right now for us to see. Okay. So after 2 rounds, so after the first round, it's like this. After 2 rounds, it becomes 100, 96, 92, and so on. And it's ending with 1, 5, 9, and 13. Right. Okay. So that's correct. That's pretty much correct. Right. All right. So I finally need to do print ARR nth element from the end. So that would be minus n over here. Nth element from the top, that's going to be minus n over here. Right. So 13 comes here. Will we pass all test cases? We will pass all test cases. Okay. Again, I just did every step by step. That's what I'm trying to do. I'm doing every step by step, and then only getting the answer over here. Right. So that's the thing. Any doubts or questions over here so far, everybody? Any doubts or questions at this point? Clear? If you have any particular doubt, let me know. If you just take every step by step, you'll be able to solve this. All right. If it's clear, please say clear. Okay, awesome. All right. Okay, thank you for that. Awesome. So then comes the question. So we looked at that. We looked at, these are all previously asked TCS Digital questions. So this is done. And this is done. So somebody's saying, can you explain in Java? Sure, let's do this one in Java. Let's have a look at this one quickly in Java. I would like to keep this open though. So give me 1 second. We'll reference it quickly on Python, but I'll keep it open over here as well. Yeah, here we go. Okay, we'll do it in Java. All right, let's go step by step in this one. Again, in Java as well. So what's the first step that we did over here? First, what we want to do is we want to create, let me just do it here. We'll do the usual public class main public static void main string args, right? And import java.util scanner. Let's do star over here. Okay. I do the usual stuff. Scanner scan is equal to new scanner system.in, right? Okay. Then what do? I say, int m is equal to scan.nextInt. Then I'm going to have m groups, right, or pile sizes. So I'll say stack sizes. Let's say so int stack sizes is equal to new int m. That's many stacks I'm going to have. I'll go for int I equal to 0, I less than m, I plus plus. These are how many stacks I'm going to have. And then I'll just say stack underscore size of m of I is equal to scan.nextInt. So I'm just taking the input here. And finally, I'll have int n is equal to scan.nextInt. It's just for me getting the input part. Now what is it that I want to do? First, I need to create the array. So I say int arr equal to new int 100, because there are only going to be like 100 elements, and I will just go through it for, I want to do top to bottom, by the way. So I'll do I is equal to 100, I greater than equal to 1, I plus plus, right? And or the other way around. Let me just start at 0, but I'll put 100 over there. I less than 100, I plus plus. I'm going to do arri is equal to 100 minus I, right? So at arr 0, I have 100, arr 1, I have 99, and so on. So I filled this array accordingly. Okay, cool. I filled the array. All good so far. Perfect. Now what, right? So now what I need to do is I need to go through each stack size and create that many stacks, right? I need to actually create those stacks. So what I'll do is I'll go through all of the stack sizes. So I'll say that, you know, int, let's say I equal to 0, I less than m, 0, I less than m, I plus plus. And now I need to create a 2D array so that I can actually track the stacks of each one of them. Now, how do I do that? What I would rather do is I'll create, because I need a 2D array here, right? So I'll create a 2D list instead of a 2D array. I'd prefer that. So I'll say array list integer. You could also create a 2D array, actually, not an issue as such. I'm just trying to think of both the pros and cons. Do that. Okay, let's go for that. Array list integer, right? Current stacks is equal to new. Okay. Right. So this is there. So it created array list current stacks. Now, and current size, int current size is equal to stack underscore size of I, right? So this is the current size. Now I'm going to go from top to bottom. Again, remember this, I want to go from top to bottom and keep distributing into the different stacks. So what do? I say for int I is equal to arr.length minus 1. Can I use I here? No, I will not use I here. I'll use j here. This is j greater than equal to 0, j minus minus, right? I'm at the last one and I'm going all the way up until the 0th element, right? I'm going there and I'm going to put them into different stacks, right? I want to put them into the different stacks. Now my issue here is, okay, this is my current size. So I need that. No, it's not my current size, brother. It's my current number of stacks. That's the thing. It's not the current size. It's my current number of stacks. Even this is not the stack size. This will be stack number, right? So let's call this stack number just so that we are, I mean, it's just a name, nothing in a name as such. Yeah. So this is stack number. Okay. So these are the number of stacks I'm going to have, right? And instead of doing it like, so I created a new, these are the current stacks. Now I need to create that many empty stacks also, right? I want to actually create that many empty stacks. So I'll go for int, let's say j equal to 0, j less than current number of stacks, right? J plus plus, and I'm going to say current underscore stacks dot add new array list integer. It's all an empty stack right now, but I want to initialize that many number of stacks. So I initialize those many number of stacks over here. Now I'm going to go from the end of the array, like from 1, 2, 3, because That's the top. And I'm going to distribute to all of these. So I'll say int my stack is equal to, I'll start with the 0th stack or the first stack, whichever. I'm going to start with that. I'm going to take the first element and put it on the first stack. So I'm going to say, okay, current stacks dot get my stack, get that element, dot add ARR of J, right? Add this element. Get the latest, get the stack I'm on right now and add ARRJ. I will do my stack is equal to my underscore stack plus 1 modulo the number of stacks I have over here. How many stacks do I have over here? You have the current number. These are the number of stacks that I will have. So now I'll go to the next stack, right? So this will keep happening. And finally, now in my array, now I need to combine all these stacks again, right? From which one will I combine? I need to flip it. Sorry. First of all, let's actually just flip the entire thing and then we'll go ahead, right? All right. How do I flip it? Now this is an interesting part, right? How do I flip this in Java? In Python, we know that. Is there a dot reverse in array list? If I remember correctly, is there a dot reverse in array list? Yeah, because I don't know the syntax specifically. You can always just do the brute force way. There's no issues there. So yeah, once I put them in each pile, I'm now going to go through each one of them and reverse them. So I say, okay, for int, let's say j equal to 0, j less than current underscore stacks dot size j plus plus. I want to go to all of them and I want to reverse them. Let me just write a separate function for that. So current underscore stacks dot get j is equal to reverse of current underscore stacks, or the better way to do it is not equal to, there's no equal to like that. You say dot set of current underscore stacks dot get, right? That makes sense. Get the jth stack, reverse it, and then put it there. Okay. So now all of them have been reversed. Finally, what do we have to do? We have to combine them all, right? Starting from the last stack all the way up to the first stack. You just keep appending them, right? So how does that go? I'll go for int. Again, it's the same thing as here, but instead I go from the last to the first stack. So I go to the last, current underscore stacks dot size -1. I started the last stack. Go to the first stack. Am I getting the order correct? What should happen finally when we're combining them? Yeah, we're going from the last to the first stack, right? Yeah, that makes sense. Okay, cool. So we're going from the last to the first stack and we want to combine them. So I will take a particular stack right now. So we just want to combine them, right? So when we want to combine them, how do we end up combining them? Okay, I'm just a little bit confused here. Bottom to top, bottom to top, bottom to top, bottom to top, right? Okay, that's simple. All right. So we do it here. Whatever is the current stack right now, we just need to get that. So let's say we need to go through it and add all of its element to the bottom of our ARR, right? So I go something like this, int, let's say x is equal to 0. We're all starting at x and we start going through for int, let's say, k in current stacks dot get j, get the jth stack, right? And go through all the elements in that. I'll say ARR ARR of X is equal to K X plus plus, right? I'll go like this, go to the next stack, and then bottom to top, we are adding all of it. All right. Okay, cool. So if we do this for all the stacks, right? Is this correct? Just trying to get a figure. Yeah, stack number of I, and then finally we just print the array. We don't print the array. We want to print the nth element from the end. So I say system.out.println. I want to print ARR. Nth element from the end will be nothing but ARR dot ARR of ARR dot length minus n. Be the nth element for the end, right? So let's just see. Okay, 34. Yeah, should do minus minus. Yeah, we didn't write the reverse function. So let's quickly write the reverse function. Public static void, sorry, not void, array list. I believe there's a reverse function there, but I just don't want to take the chance and writing my own. Okay. Let's say answer is equal to new, right? So create the array list, and then what do? You go through it for int I equal to 0, I less than answer, sorry, I less than this should be original. I say I less than original dot size. No. Yeah, we can just do that. Size I plus plus. We keep adding at the start. Instead of adding at the end, we keep adding at the start. So I say answer dot add 0. Add at the position 0 the original dot get I, right? Add that, and you just need to return. Just need to return answer. Okay, that should be that. Okay, there's no original dot size. It has to be a method. Yep. Dot set cannot be applied to given. Yeah, we cannot just do dot set, right? I think dot get also works fine over here. Dot get equals to should work fine. Dot get cannot find K. Oh, yeah, it should be J. Sorry. Unexpected side. Type J. 1 second. Why is it? How do you get something at index? How do we get the index at that point? How do we get at particular index? Anyway, I think we can actually just avoid this part and just do the reverse. But how do I get the index? I got the index here. Why am I not getting the index here? Okay, not an issue. We'll just, yeah, we'll have to do it a little bit. Yep, not an issue. Array list, integer, let's say this stack. So whatever the stack I'm in right now, this stack is equal to whatever it is, right? And then we say this underscore stack is equal to reverse of this underscore stack. Because it's all by reference, it should work out. All right, so my output is 4, but it should be 13. Interesting. All right, so let's just go and try to print out all of the elements that are there. let's see if all our stacks are working out correctly or not. So for string, it's not string, sorry, for int x in this stack, let's just see. Okay, so it is giving us 99 and all over here. Yeah, but we'll also just see all the stacks are coming correctly or not. Seems to be that the stacks are correct. Yeah. So first stack is in reversed order is like this, which is correct. Second stack in reverse order is in like this. It is correct. Yeah, so we did that. And then, yeah, 1 second. Let's just see if it's actually reflecting over there. Yeah, no, it's not getting reversed. That's the issue. That it's not getting reversed. Okay. Oh, okay. Because we didn't do one thing. Okay, so we'll have to create another 2D array with the reverse stacks. Although I have a feeling there is a better way of doing this. But okay, how do I set it at that particular index? Why am I not getting that dot set? Okay, I might be missing a few things here, but the thing is, after it's reversing, it's not reflecting in the original array. That was the issue. It's not reflecting in the original one, in the original stack. So we need to figure out a way of how to do that. Oh, okay. Yeah, now I got it. Yeah, I remember now. Current underscore stacks, I believe stacks dot set at index j this underscore stack. Right? This is what it should be. Yeah, this is not giving us any. Okay, set this. Fair enough. So let me just bring that back. Let me just do this. Now let's see if it's giving us the reverse. Okay, so now it's giving us the reverse, right? So it's reversing it. Here also it's reversed, but our final output is still not coming out correct. Let's try to see why. So it's been reversed there. I'm starting at the last stack. So after reversing, okay, this is after reversing, that's good. But for some reason, int x is equal to 0, int k. Oh, okay. I think I got the issue. Yeah, int x equal to 0 should happen here. Yeah, now it's giving the correct answer, right? We were setting x to 0 every time. So we were only setting ARR 0 up until ARR 10, let's say. We're not setting it again and again. That was the issue, right? So that's how you debug, everybody. That's how you have to debug. If I run this, it works out. And I believe I submitted, it does work out. So I hope you got it in Java. Java, just the only issue is that 2D lists are a little difficult to maintain. So I had forgot the syntax for a couple of them. Right. I hope you understood that in Java right now. Is that clear? Is there any line of Java that you would want me to repeat for you? The student who asked me to explain in Java. Okay. All right. Okay, everybody. So we'll have a quick look at Sultan sum. We'll look at this question called Sultan sum really quickly, right? Okay, so I discussed this last time. For those of you who don't remember, you can check my previous recording. But what I discussed was you basically need to do an n queens on this one and generate. You actually need to generate all of the possible places in which you can place the queens such that none of the queens are attacking each other. So that's what we need to do. We need to place the queens such that none of them are actually attacking each other. And we are always given an 8x8 board, so we don't have any issues there, right? It's an 8x8 board over there. So we can actually just hard code the value 8 and place all the queens in such a way that none of them attack each other. Very quickly, if for those of you who probably don't remember n queens, it's like, let's say I've given you an 8x8 chessboard, right? So something like this, let's say, right? So this is the 8x8. Let's say this is the 0th row, right? Right, 0th row, 1, 2, 3, 4, 5, 6, and 7. Right. In fact, actually, I'll just give you, let's do that here. It's always better here so that we can see if the queens are attacking and whatnot. Right. It's always better to do it on Excel over here. Sorry, 1 second. Yeah. So let's assume you have a 8x8 chessboard. Assume this is your chessboard. Okay. Right. So this is your chessboard over here. Okay. Now you have to place the queens in such a way that they don't attack each other. What do I mean by they don't attack each other? Let's say if you placed your queens like this, queen, 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 and let's say queen like this. Right. Obviously, they're attacking each other, right? Because any two queens, like this queen attacks this one, this attacks this one, then attacking the same element, right? So you can't have it that way. You need to make sure that whenever you're adding a queen, wherever you're adding the queen, they're not attacking each other. Now, the only way to do this is actually to do a, an n queens method, where it's a backtracking approach, where what you do is you place the queen here and then you see, okay, can I place it here? No, you can't place it here. Can I place it here? No, you can't place it because it would attack. Then I can place it here, right? Let's say. Then in the next row, I can't place it here, 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 here. So I could probably place it here. Okay. In the next row, can't put it here. Could put it here, right? Because it's not getting attacked from anyone specifically. Then in the next one, can't put it. No way I can put it here. Can I put it here? No. No. Yes, actually, I can put it here probably because this diagonal is like this, right? Yeah. So it's not really forming in any diagonal over here. Right? So I can put this queen over here. Then this can't be put here, can't be put here, can't be put here, can't be put here, can't be put here. Can I put it, somewhere over here? No, this it can't because it's the same diagonal, right? Okay. Let me also color each diagonal, by the way, so that we are at least knowing of the diagonals. But you can have the other diagonal also. Anyway, okay. So where did I come by? This can't be here, and this one is all the way over here, right? What about this one? Yeah, this diagonal is also covered. So I can't really find a way to put this queen anywhere, right? So this is probably wrong. I can't put the queen here. Can I put the queen here? No. Can I put the queen here? No. Again, the same diagonal. Can I put the queen here? Diagonal with that one. So I could put the queen over here, right? I can put the queen over here. It's not interfering with everyone. Can't put it here, not here, not here. Can I put it here? No, same diagonal as this. So can't put the queen over here. Can't put it here. Can I put it here? Sharing the same diagonal as the original one. So can't put it there. Can I put it here? No, because of this queen. Can't put it here. So this does not work, right? And so on. So what you'll do is then you'll try to keep this queen not here, but you'll try to keep it here. Can't. So it can't be put here, can't be put here, can't be put here, can be put over here because it's not interfering with anybody. as yet, and so on. So you keep trying to put the queen in a certain position, and then you generate the combination. Now the question is not just to generate all the combinations, but rather it is to say, in all of the possible configurations of the queens, what is the configuration that will give you the maximum sum? Now what they've done is, with each element of the chessboard, they've associated a score. So what you need to do is say that, okay, in all the possible configurations, the scores that you will actually end up getting, what is the maximum that you can get, right? So that's what we'll have to do. I'll quickly just do the n queens for an 8x8 for you all, just so that you guys understand. We'll take this part later, but let's just take an n queens for an 8x8, right? So I'll say that we want to create an 8x8, right? So let's say I say the board is equal to 0 for I in range. I'm sorry, for j in range 8 for I in range 8. So we create an n cross n over here, okay? And just to print it out to show you all, right? It's an n cross n. What happened here? In. This is an 8x8, just full of zeros, right? It's just full of zeros, nothing else. We need to figure out places to put the queens. So where do I do that? So I'll say, all configurations is equal to n queens for this board. Do n queens for the board, and here is where our here is where what returns. Here is where that will return our backtracking array. So I'll go for this one, n queens, right? And I have a particular board over here. All right. We'll also get the current queens where all they are placed, right? So initially speaking, the current queens are not placed anywhere. Current queens are not placed anywhere, and we'll just pass it on here. Right. Okay. So what are we going to do? Again, for backtracking, as I was saying that day, assume you're in the middle always. So you need to know your current row number also, right? So let me put the row number also here so that you know which row you're in. Assume you're in a particular row and try to see if you can place the queen over there or not, right? So I'll say for j in range, and I know it's 8, so I'll just go through like an 8x8 every time. For j in range 8, I'm going to try to place the queen at a particular spot on the board, right? And see if that works out or not, right? So how do I place the queen at that spot where I can say, current queens dot append whatever the row number you're on. So I'm going to append row number, comma, this is a tuple that I'm appending, comma 8. And this is the column number. And I'm saying that, okay, see if this, works out or not. If it works out, great. If it doesn't work out, then you have to erase this one. So what am I going to do over here? I'm going to say, okay, let's append this, and you again try to do n queens. You again try to do n queens, but this time with this new current queens, go to next row, right? And with this board, I have a feeling this board is not going to be useful anymore, but let's see. Okay. So I did it. It would return something to me. It should ideally return something to me that either, it worked out or, it didn't work out is what it actually should return back. So let's say it did work out, right? If this was a particular, okay, I think, yeah, we've got it, right? So we have all configurations, right? We don't need to do that. We can just do all underscore configurations is equal to like this. Just keep a blank one here. And yeah. So now what you'll do is you'll return true if it worked out, and you'll return false if it didn't work out. So I'll say, let's say answer is equal to this. If it worked out, great. If it didn't work out, then, so if answer is, if it's true, and you know what, because we need to generate all the configurations, even if it's false, we will still go on to the next one and try it out, right? So even if it's false, we're still going to, okay, it didn't work out for this row, so sorry, if it worked out for this column, great. I'm still going to go to the next column and try out because I need all of the configurations, right? So actually don't do anything over here. All I do is I erase what I did just now, right? So I say current underscore queens dot remove row comma j. I want to just remove this one because now I want to go to the next possibility. So I'll say, you know what, remove this and go again to the next one. All right. This makes sense. Okay. Now it'll keep going. We need a base case. Okay. So first things we'll check is if is valid current underscore queens. First of all, if it's valid at all, right? If it's valid, then great. But if it's not valid, right? If it's not valid, then you just return false directly because it's of no use. But if it is valid, right? So else, let's say if it is valid, then we'll also check that row equal to let's say 8, or let's say greater than equal to 8. So now we've basically come to the last, we've come to row 8 and we've not had any issues with all the queens so far. So that means it was valid so far. So then I'll just do all underscore configurations dot append current queens, right? This is what I'm going to do. So I'm going to append this, whatever is the configuration of queens that you have got so far. This is what we're going to do at this point. Okay. That's about it. Otherwise, this is the case, you know, we append this and again, we return true at this point, right? We return true at this point. Although this false and true don't really matter because we're going to try out every possible things at any point anyway. So, right. And this all underscore configuration needs to be a global variable. So let me just actually define it here. Yeah. All right. So as I said, board, I don't think we really need it at this point. We can actually do without the board and without the board over here. And we'll also do def is valid. You know, let's say queens config, whatever the queens that they've given us, we'll check if it's valid. What do I mean? How do I check if it's valid or not? Well, I'm always going to check, first of all, if queens underscore config, let's say len is equal to 0. That means I've not even started. This is my first attempt. Yeah, you return true. It's correct only, right? If it's true so far, then it's fine, right? Otherwise, that means that the length is greater than 0. So what am I going to do at this point? I want to check if any one of them share the same row or the same column or the they share the same row or the same column or the same diagonal, right? So how do I check that? I'll always check the latest one, right? It's always useful to check the latest one. So latest queen is equal to queens underscore config of -1. Take the latest queen that you got, right? Check it with all the previous queens over there. So I go for I in range len of queens config -1, right? Go till the last but one element and you check, is my latest queen of are they in the same row, right? Or they in the same column. So how do I check with them in the same row? They will not be in the same row, by the way. It's not possible for us to have them in the same row. So we can check in the same column. So I'll say, but still, let's just check it out. Let's if latest underscore queen of 0, right? Because that's the row, is equal to queens config of 0. If this is the case, return false. It's not valid because they're having the same row, right? Same thing here for their column, right? Again, you return false. Then what do you check? You also check if they're in the same diagonal. How do I check if they're in the same diagonal? This clue will also give you of how you can solve the Sudoku solver question, which I think was also given to you all. So let me just put this here. The elements that are on the same diagonal, if I just take this board, over here, what you end up getting is this, on this diagonal, you have 0, 0, 0 comma, let's say you have 1 comma 1, you have 1 comma 1, 2 comma 2, 3 comma 3, and so on, right? In this diagonal, what do you have? You have 0 comma 1, 1 comma 2, 1 comma 3, right? Sorry, 2 comma 3. Then here 3 comma 4, right? Here it's 4 comma 4. So basically what's happening, and if you check over here, what is it? It is 1 comma 0, 1 comma 2, 1 comma 3, 1 comma 4, right? So what's, if I take this diagonal, what is it? Sorry, it is 1 comma 0. This is 2 comma 1, 3 comma 2, 4 comma 3, right? So here what happens is, if you just notice, the I minus j value is always being constant. I minus j value is always constant. In these, you know, from like that side to this side, which is basically from your northwest to southeast, in these diagonals, right? What's happening always? Your I minus j is always constant, or your j minus I, whatever you want to call it, but your I minus j is constant. So if two queens share the same this diagonal, then their I minus j will always be constant. So I say that, okay, their I minus j, if the latest queen this minus j being 1 over here, right? If this is equal to 1 second, we need to do I over here. I of 0, I of 1, and I of 0. I of 1, right? Okay, all the brackets are there. If the I minus j is equal, you return false because they're on the same diagonal, right? Similarly, how do I get the other diagonal? So this will be 0 comma 7, 0 comma 7. This will be 1 comma 6. This will be 2 comma 5. So the I plus j value is constant here, right? 5 comma 2, right? I plus j value is always constant. If you check here, it's going to be 1 comma 7, 1 comma 7, 2 comma 6, sorry, 2 comma 6, 3 comma 5. So again, the I plus j value is always constant in this case. So in this case, what I check is, instead of doing minus, I say, okay, right. Otherwise, if this is also equal to whatever is the value here, right, I will return false again. Now in this, if I did not find a single queen that I'm conflicting with, I will return true. Yeah, that yes, it's valid. So in your n queens, this is actually the most difficult part. I'm just writing the valid function. Otherwise, it's all okay. So if all of the current queens are fine, right? If the array is fine, then you say, okay, cool, awesome, right? Otherwise, you append this current queens, and in fact, even appending the current queens is not a good idea because this is being passed by reference. So what I'll do is I'll just say, let's say current answer is equal to for x in range, or for x in current queens, let's say current is dot append x. We'll copy the value, and then we're saying, okay, take the current answer. So this way we should get all of the possibilities of the queens. Let's try it out and see. We don't need this board, and let's just remove board from everywhere. Okay. And then what we can do is we can say, let's just print out all underscore configuration, or rather, or see in all underscore configurations. So let's see. Right, let's try to print that out. Invalid syntax. Yes, I don't think this works. You have to do not. So, okay. Name row is not defined. So this is in line 43. Yeah, this should be 0 by the way. All right. So we are getting these many possibilities of the queens, right? We're getting these many possibilities. Okay, it's not printing the entire thing. Possibly we're seeing too many possibilities. Let's take one possibility and see if it's correct or not. Right. So let's try to do that. Yeah, let's take this possibility and see whether we're getting the correct one or not over here. Okay. So I'm just going to put that here. All right, so this is one possibility. Let's just see if this possibility is correct or wrong. All right, so this comes out to be something of this sort where 0, 0, 1, 4. Okay, so far so good. 2, 7. That's also fine. 3, 5. Looks okay. Not interacting with anybody so far. 4, 2. Is this on anybody's diagonal? Not on anybody's diagonal. So good so far. 5, 6. Again, not on anybody's diagonal. Yeah, not on anybody's diagonal so far. 6, 1. This is this Q. Right? No, not on any diagonal so far over here. Okay, and 7, 3. All right, so this looks correct, right? This queen has been placed correctly. It's not really attacking any queen, just saved. Okay, fair enough. So I think we are getting, so all of these configurations look correct. So we just need to generate this once. We got all the configurations, right? So now we've got all the configurations. Now we can take input the board that they have given, right? Now we can take this particular thing as input. So I say, first line contains what? First line contains number of words. Okay, so let's do that. Let's take that. K is equal to int input, right? And yeah, we didn't need this board then. Now we can do it, and we can say for I in range 8. Say board is equal to list map or other current row map int input split. I do this, and now I'll append. So board dot append. This is how I like to take a 2D array. If you guys like to take it in a different way, up to you all. So I take the particular board, and now what I'm going to do is I'm going to go through each of the n queens possibilities, right? And see if the sum that I'm getting is, which is the greatest sum that I can get. So let's say total is equal to 0. Okay, and I want to go through all of the possibilities that are there, right? And by the way, this is the number of boards, so I need to do this for each of them. For test case in K. Again, create the board every time. Right? So my current total is 0. I will say, okay, for I want to go through all the configurations. Let's say for all, let's say for, let's say config in all underscore configurations. Right. So this is for all the configurations that we have out there. This will be a list, right? So for position in config, right? I now got a position. This is an x, y value, right? So I'll say total is equal to total plus board of position of 0, okay, position of 1. Get whatever is the position at that point. This will give you the total value. Total is equal to total plus that position 0 comma position 1, right? So I got a particular configuration here, the total thing. And I'll also get like max total is also equal to 0. I'll put it here. And this total 0, I should do it before every configuration. And I say max total is equal to max total is equal to total comma max. Right? I try out all the configurations and then I print max total over here. So if I run this, not people, all right, no issues. Yeah, should be like this. The 2D array, this is how you call it, right? So yeah. So we got that certain configuration, whichever configuration that is giving us a sum of 260, right? So that was our correct answer. And if I submit it, that works out, right? So what did we do here? We first generated all of them. We are not generating for each board the optimal, because we know it's an 8x8. And if we know it's an 8x8, I know that I can, like in an 8x8 chessboard, you whatever the scores you give it, whatever scores you give to each square, there are only certain ways in which you can store the queen. So I figured out how to store the queens. That I did the backtracking approach and generated it, and I stored it all into all configurations. In the all configurations, it's basically a list of 8 coordinates every time. And those 8 coordinates tell us how many elements or how many ways are there in which you can place those 8 queens. Now, if that was it, would be fine, but that was not it. We're saying that of those configurations, if we assign a score to each of the square, then what is the maximum sum that you can get? Like in which configuration you can get the maximum sum. So we said the maximum sum possible for this is 260 over here, right? Okay. So yeah, that covers our last question as well, which is n queens, which we did. And as part of that, we did the Sultan sum as well. For wander paths, everybody, just so in case of Java, we can consider 2D array. Somebody's asking. So in case of Java, we can consider 2D array. Yeah, you can. I mean, in which part do you want to consider the 2D array? The board will be a 2D array. You're talking about a tuple to get the x comma y value. Yeah, you can consider a 2D array, because here we used a tuple over here, but you can, for the x comma y, you can use a 2D array. Yeah, you can use a 2D array over there. What you'll basically do is you can also just use a list. So what I'm doing here is all configurations, I'm appending the new answer every time, right? At that time, this all configurations will have to be a list for Java, an array list, right, in Java. And when you're taking this, this row comma j, you can pass a new array, a 2D array is what you can pass over there. Right? So at every time, you can just append a new 2D array over here. That's fine. Or a 2D list, whichever you want. That's also okay. Okay. Thank you for the question. All right. So everybody, that's all. We'll pause here. Wander paths available on Code Vita Marathon. Just go check out the Code Vita Marathon on Edyst. I'll make sure that you also get that somewhere. We'll update the wander paths in your course, and you can also check the solution for that. I'll share that solution also for you guys. Right on. You'll be able to see the wander paths in the TCS Digital section. Like this one, Sultan sum is available on the TCS Digital, right? So you'll see your wander paths over here, and you will also see the solution of that. Solution is already, solution will be present there. So you guys can check that out within the next 10 minutes of this session. You'll be able to check that out. Okay. So everybody, thank you so much for sticking, especially on the solution. I just put this here, solution to be uploaded. So yeah. Thank you so much, everybody, for sticking, especially on a Sunday afternoon. For all the students who are still here, thank you so much. Wishing you all the very best for your TCS Digital, for your upcoming TCS Digital rounds. Wishing you all the very best. And yeah, please stay tuned to this channel and to your courses. We are going to cover many more such questions in the upcoming rounds as well. Okay. All right, everybody. Thank you so much, and all the best.